Morning, class. We're going to go over a couple things today. First is we're going to write biconditionals. So we're going to pick up where we had conditional statements and converses yesterday. And then we're going to recognize a good definition. So again, this isn't your typical math class. You're going to be writing out sentences today. So first of all, what is a biconditional? So what we're going to do is we're going to look at a conditional statement and its converse. And if both of those statements are true, then we'll write a biconditional. Biconditional is just, we're writing a phrase using the words if and only if. So biconditional is if and only if. Example, if two angles have the same measure, then the angles are congruent. So again, conditional is an if-then statement. The converse, we're going to switch the hypothesis and the conclusion. So if the angles are congruent, then the angles have the same measure. Now, we look at it. Is it true? Two angles have the same measure, then they're congruent? Yes, that's true. Is it true that if angles are congruent, then they have the same measure? Yes. So since both the conditional and the converse are true, we'll write it as this. We start basically with the beginning. It's not an if-then. Two angles have the same measure if and only if they're congruent. So we're taking away the if and then, and what we're replacing is the if and only if. At the middle. If and only if. We're replacing that. So we're writing it as a statement now instead of a condition. Again, if 3 points are collinear, then they lie on the same line. We'd say if they lie on the same line, then the points are collinear. Now we're looking, is it true? Is this true? 3 points are collinear if they lie on the same line? Yes. If they lie on the same line, then they're collinear? Yes. Since both of them are true, we go back to the beginning. 3 points are collinear if and only if they lie on the same line. 3 points are collinear if and only if they lie on the same line. So as we go forward, what we want to do now is we have a biconditional statement. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. We take that, we're going to write two statements. We're going to write a condition and then its converse. So we start off with if a number, so you start out, if a number is divisible by 3, then the sum of its digits is divisible by 3. And now statement 2 is the converse. Now we switch the order. If the sum of the digits is divisible by 3, then the number is divisible by 3. So anytime we can go through, we can break down a biconditional into a condition and its converse. Biconditional statement, a number is a prime number if and only if it has two distinct factors, one in itself. Again, we'd say if a number is a prime number, then it only has two distinct factors, one in itself, and then we state the converse. If it only has two factors, one in itself, if a number has two distinct factors, one in itself, then the number is prime. So now we're going to look at a definition. So definition, we want to be clearly understood terms, precise. We don't want to use all, large, some, sort of, always. And then it's reversible. So this is what we're going to be looking at. It's reversible. Both ways. So like condition and its inverse. So we're going to use it. A good way to write a good definition for us is a biconditional statement. That definition, perpendicular lines are two lines that intersect to form right angles. So let's go ahead and state it. If two lines are perpendicular, then they intersect to form right angles. Is that true? If that weren't true, then that's not a good definition. Now we'd state the converse. If two lines intersect to form right angles, then they are perpendicular. Is that true? Two lines intersect to form right angles. Yeah, then they're perpendicular. Yes. So both of these are true, so we can write it as a biconditional. And we'd say two lines are perpendicular if and only if they intersect to form right angles. Right, so we're always checking. If one of these were false, whether it's conditional or the converse, then we'd say it's not a good definition. Definition, a right angle is an angle whose measure is 90 degrees. So again, condition, converse, and then our biconditional. So we'll start off with a conditional. If an angle is a right angle, then its measure is 90 degrees. Converse, okay? If an angle measures 90 degrees, there we go. If an angle measures 90 degrees, then it is a right angle. All right? True, true. So now we can write it biconditional. An angle is a right angle if and only if. There we go. Right angle if and only if its measure is 90 degrees. This biconditional always basically started from your condition, from here. Don't start it from your converse, but start from your condition. Go from there. An airplane is a vehicle that flies. So, is this true? Is this a good definition? So, if the vehicle is an airplane, then it flies. That would be a statement that we could say. We want to write it as a condition. If that, so an airplane is a vehicle that flies. Is it reversible? So think about it. All right. If a vehicle flies, then it is an airplane. Is this true? If the vehicle flies, then it is an airplane. Is there any other vehicle that may fly that's not an airplane? Well, a helicopter. So it's not reversible. That's a bad definition. All right. A triangle has sharp corners. Is that a good definition? Well, no. I mean, you think about a square or a rectangle. Those have sharp corners, right? Very vague, not a good definition. So that's what you're going to be looking at. Is it reversible? If it is reversible, then we can write it as a biconditional. So biconditional, remember, is if and only if.